Starting with the title of this presentation, which is Lessons and Best Practices Learned from Monitoring Next Generation Infrastructure. So I'm here to talk about monitoring, specifically metrics-based monitoring. Now that has been around for many years, but what makes things interesting is that certain industry and infrastructure trends lately have been posing a new set of challenges. So the question is, what are some of those challenges? What can we learn from them? And what are some of the ways to deal with these? So that's what I'm going to be talking about. And we'll do that by following 4 specific examples. These are things that we've been seeing. Now, this is not meant to be exhaustive, and sort of your mileage may vary, but I mean, we are seeing this across a broad cross-section of our customers. So I hope that some of these will resonate with you. And we're obviously always very happy to hear from you about your experiences later on. A little bit about myself. So I've been working on monitoring for more than 10 years now. For the last 4 years or so, I've been at SignalFX, which is a sort of a metrics SaaS that provides monitoring and operational intelligence for the cloud. And working there and working with our customers and our partners and our prospects sort of really helps give us a broad sense of what's going on in this space. And before that, I was at Facebook, also mostly working on monitoring. Team that built their metric system, which is called ODS, from scratch. And over the course of my career, I've had a chance to work with sort of the back end, but also the front end, and in teams and with teams that have been users of monitoring services. All right. So before we begin, what do I mean by next generation infrastructure? Next generation infrastructure means a lot of things. It provides a lot of value. But in general, I think certain aspects of them really stand out. I think they are speed, efficiency, and cost. So speed, for example, a startup like SignalFX can deploy a lot of compute really quickly thanks to the public cloud, so it provides a speed. Efficiency, because I can run multiple containers or I can virtualize a server to extract more value out of it by running more things, so it provides me with efficiency. And cost, because there are a lot of on-demand elastic services that I can build and then I can tear down when I don't need them, thus paying only for the time that I'm using them for, right? So there's various different things that are here, and I don't want to get into sort of the details of these now because as an audience, I think you're pretty familiar with all of this. So my main motivation for this slide was to put in sort of as many cool buzzwords as I could into a single slide, because my marketing team here, they coached me that this is a smart SEO strategy. And you'll notice how I try to attract the artistic demographic here by putting some Nobel Prize winning literature in the title. That's a Bob Dylan song that I'm very, very fond of. All right. So let's get into the lessons. So what are the lessons? The first lesson I want to talk about is that there are way more metrics than you might expect. Right? So the job of any metrics time series system is to basically capture and work with time series data. And a time series is when some source, let's say a server or a container, measures some quantity like CPU or memory periodically over time and sends it to you. And the metric system is in charge of storing them in some kind of a time series database, making it available for querying, and also analytics so that you can sort of visualize it and alert on it, right? And when the number of metrics goes up, it's a problem because it's harder computationally to deal with it. For example, querying 10 data points from 100 different rows is usually much more computationally expensive than, say, querying 1,000 data points from a single row, right? This is why the number of time series matters. And before we get into this, let me sort of do a little pop quiz. So let's say you had n servers in your environment. How many metrics do you think you should provision your metric system for? You could say that it's n times 10 because you just want to capture the key sort of important system metrics by like CPU and memory and all of that. Or much better, you could go with n times 100 because now you can not only capture your system metrics, you can also capture lots of application metrics, which is kind of probably where the value is, right? You could put in a 2x multiplier because, hey, future growth, we are all growing. Or maybe n times 1,000 because, hey, you have a lot of money, maybe your company just got acquired, I don't know. If you've been able to keep yourself awake thus far, and if you've seen my previous slides, you probably know what my answer is going to be here, right? And the answer is a clear none of the above. And why do I say that? So at SignalFX, we are sort of a data-driven company. Our product is data-driven, and as well as the company is data-driven. So we looked at what are we seeing from our customers? What kind of multipliers are we observing? And the answer is that n times 1,000 is actually very common. It's more common than you might expect. A lot of our customers are doing that. We are seeing extreme multipliers. We are seeing 20,000, 30,000, which seems kind of unbelievable at first, and we'll get into why. So that seems to be the reality, right? So let's get into why this may be happening. I think there are sort of multiple different contributors to this. The first one is microservices and right-size instances. So the trend nowadays is to build loosely coupled microservice-based software, right? Instead of large monolithic software. And when you do that, and where each microservice is scaled and operated independently, the number of things that need to be monitored is obviously going up, and that amplifies how many time series you might receive. The second one is containers, and it can be huge too. We tend to run multiple containers in a single service instance running on a single server. For example, Kubernetes pods act that way. So when that happens, now there are more things to monitor again, because I have multiple containers which are all sending their own set of metrics. That provides some amplification. But I think the extremely large multipliers that we saw earlier, I think that happens because of fine-grained monitoring, where customers care about things that have nothing to do with their infrastructure or their servers, and everything to do with something else. And per customer monitoring is an excellent example of that, where they want to maintain a set of metrics about their customers, because why not? They have a metric system. And this can provide huge multipliers because it depends on the number of customers that they have. And this is not unique. We see this as a trend. Customers are actually monitoring various different things. They are monitoring jobs and orders and loans and searches. I mean, you get the idea, right? So this is why we are seeing many, many more time series than you might expect. So what are some of the things we can do about it? The first thing I think is the realization that a server-centric estimation of monitoring capacity, that idea is dead. It really depends on your environment and your use cases, fundamentally, because even a small company or a small organization or a team can have a huge footprint in how many time series they are generating, right? And so that's the number one realization. And the second thing, as I mentioned earlier, is that it's not just about number of data points. For example, you can have a time series database that can sync a lot of data points, which is great. They should be able to do that. But it's also the value you're extracting out of it. And the number of metrics matters because it can get more or less efficient based on how many you have. And so that is an important consideration, right? And so the main message is, as you're building or choosing or deploying a monitoring system, be very careful, think about your environment and plan accordingly, okay? So the next lesson that I want to talk about is about historical reporting. Historical reporting is when we are trying to look at data far back in time, right? And so far what I've been talking about is current things. For example, things that are reporting data to me right now. But what about data and time series that came to me in the past? In order to do a historical report, I have to look at not only data and time series that are active now, but also on data and time series that were active in the past, right? And that can also become computationally expensive. And that's the thing that we are finding, right? And historical reporting, before we get into more details on it, is actually quite a reasonable and useful thing to be able to do. For example, you may want to track how many API calls is my service having over the course of a week. That's very reasonable to know. Or you might say, hey, how many active users or active sessions have I had over the course of the last year? You may want to know that because you want to do capacity planning and you want to sort of project where things might be later and how much infrastructure you might need later. So this is not an obscure use case. This is actually a very valid and important use case that your system should be able to answer. And as I said, the reason it's becoming computationally expensive is because of two things. You have more data points to deal with, and you have more time series to deal with. The data points case is actually much easier to grok in the sense that, let's say I have a chart which is showing me 1 hour worth of data. So it's processing through some number of data points. Now, if I expanded that and wanted to look at a day's worth of data, that's 24 times as many data points, right? And that's just a day. What if I wanted to look at a week, a quarter, a year, right? And it will linearly scale. And that means your query might become slower and slower and slower, right? The other one is amplification in number of time series that your query might have to deal with. And that happens because of this thing called churn. Churn is when time series get replaced by new ones. And it's an important enough concept that I want to spend a couple of minutes talking about it. So churn is when one time series is replaced by an equivalent other one. So let's say you had an Amazon instance with a certain instance ID, and you replaced it, or maybe Amazon retired it. So now there's a new Amazon instance with an instance ID B in this case. So now that means all the data that was being reported from instance ID A, all those time series are dead, and the one with B is now alive. And that means a little bit of churn. So now I have two time series over time, right? Docker containers, that happens when I restart, for example, a Docker container. It comes up with some new unique Docker container ID. And that means the old one died and the new one came up. And containers tend to be very ephemeral, so this can provide a lot of churn in your system. And then on-demand services. For example, let's say I have an Amazon Elastic MapReduce service that I spin up every day, and when I'm done, I tear it down. So over the course of a month, I'll have 30 times as many time series, because every day I'm getting new Amazon MapReduce instance IDs or whatnot that are coming up, right? So, and then let's say you deployed a new version of your software. So now all your application metrics are reporting with a different identity. So this tends to add up. And it can be pretty extreme. You might think that, hey, this kind of churn is not going to affect me, but it actually does, because we actually ran where was I? Okay. We ran a survey. We ran a survey to find out how much churn are we looking at from our customers, right? And this is the chart that shows that. What we're looking at here is this thing called active ratio. And I'm going to define what active ratio means. Active ratio is the number of metrics that are active now compared to the total number of metrics that have been active any time in the past year. So let's say that's the definition of active ratio. So let's say you have 10 metrics that are active now, and you had 90 that were active over the course of the past year but are no longer active now. Then you have a total of 100, and your active ratio is 0.1 or 10%. And so what you're looking at on the chart on the left is the distribution of the number of customers and their active ratio. And what you will find is the vast majority of our customers are in the 0 to 10% range. That means for every 10 time series that they're sending to us now, 90 have been sent in the past that are no longer talking. And just the sheer steepness of this curve was sort of like an eye-opener for us. Like, wow, that is very extreme. And there's a clear, well-defined pattern here. So when we said, let's look at what's going on in the 0 to 10% range, and that's what the chart on the right shows. And there again, you will see that the vast majority of the customers are in the 1% range, which means for every time series that they're sending now, they have sent us 99 that are no longer talking over the past year. So this is extreme. And I mean, these are again a broad cross-section of companies in different areas. So if they are seeing this, chances are you might too. And so what are some of the strategies and lessons one can have? The first one is to realize that churn is a very insidious problem. What I mean is that you may deploy a monitoring system, and it's going to be great on the first day. There has been no churn. Things are going to be fast and snappy. Then as time goes by, and as churn causes more and more dead time series, there are more things to store, more things to query, and things may slow down. And so it's a hard problem to fix later. So be mindful of that now, right? Because the world is moving towards a more ephemeral kind of pattern. The second approach you can do is to sort of, you can say, look, I'm going to try to prevent or fix the problem, right? Prevention is better than cure. You might say, look, I don't care about software versions and container IDs and instance IDs. I'm not going to send them. I prevent churn, right? That's quite a reasonable way to think. The problem is that what we are finding in real life is that doesn't tend to work out very well. And there's two reasons for that. The first reason is that customers do want to keep track of things like versions, because they want to know how did their different software versions over the course of the last week or month or quarters, like how did they perform? They want to keep track of these things. That's number one. And even if you didn't, it's hard to enforce, because in order to sort of report data that does not cause churn, you need to have standards, and you need to enforce them across your engineering organization, across all your engineers. And if you don't do that very well, then you're going to run into the problem again. And that kind of enforcement, what we have found, is practically hard to do, and this is why it doesn't work out, right? And so, sounds reasonable. This is probably not a very practical strategy. So then you could say, look, maybe prevention doesn't work. I'm going to try and address the problem computationally. And there is hope on this front. So for example, you can say, I'm going to cache queries. So let's say I ran a query that goes over the data for last month. Obviously, it's going to take a lot of time. But if you store the results in some, let's say, memcache, then next time you run the query after an hour, it's going to be much faster because you're going to find most of your results right away in your memcache and maybe query a little bit of data from your time series system, right? That's a good thing to do. It actually works. I've used it myself. I've seen it being used. The obvious problem with this is that it doesn't work very well for exploration use cases, right? So let's say if I'm issuing queries that are new, there's nothing in the cache and it'll be slow, right? But otherwise, if you're repeating the same thing over and over again, it's a good thing to do. Another thing you can try is to sort of reduce the number of time series that your historical reporting needs to deal with, and that is by aggregating across services, right? So let's say you have a search service that is composed of, let's say, 100 servers. You might say, look, there may be 100 servers, but for the most part, I'm interested in the health of the service and not in the instances as much. So why not create aggregates? For example, calculate the average of some metric across your search service and report that as a separate new time series. That way, for the most part, when you're doing your observation or analytics, you're looking at a single time series and not in the individual ones, right? This is also a very, very good strategy. I've seen that in use at Facebook and various other companies, and a lot of our customers sometimes send us this kind of data. The last strategy deals with data points. So we talked about reducing number of time series. You can also reduce the number of data points that you have to work with. So let's say you have a service that's very important, let's say ads or whatnot, and it's reporting metrics every second. What you can do is you could say, I'm going to calculate time-based rollups. So I'm going to calculate 1 minute aggregates and 1 hour aggregates and what have you, and report them as separate data sets. That way, let's say I'm looking at a day's worth of data, I can only query 24 1-hour as opposed to 86,400 1-second data points, right? So that can also provide a lot of help. And this is also a very reasonable strategy, so things that you can use. So that's historical reporting. The next lesson I want to talk about is about holistic monitoring. Our environments are becoming more and more diverse and complicated, and it's hard to get a sense for how things are doing holistically. And that's a real problem. So this picture, kind of while funny, is also sad, right? We are seeing this on an everyday basis. So SignalFX as an application is nothing special, it's quite standard. We have Java and Go code that is running in Docker containers that are housed in Amazon instances. So just look at the different types of metrics that we have to deal with every day. There's host metrics because we deploy a collector agent, collectd, on our servers. They're reporting system metrics to us. There's container metrics because the Docker containers that are running our applications are reporting their own set of data. There's application metrics because we instrument our source code to report the important things that we want to measure and monitor on. There's cloud provider metrics. For example, Amazon provides us cloud metrics about the instances that our services are running on. Business metrics. How many active sessions did I have? How many active customers do I have? How many queries did I serve? Stuff like that, which are useful, especially when combined with some of these things. And there's third-party metrics. We use a lot of open source and third-party software like Zookeeper and Elasticsearch and Kafka and whatnot. All of them also expose metrics. And the sad part is that there is no common standard, right? So there is no common standard across all of these. They're all doing things their own way. They're naming things their own way. What that means is it's hard for me to look at things holistically, and the tendency would be to go and look at things sort of in a patchy, sort of piecemeal fashion. And that's a problem, because if you ask different people in your organization about what they want, you will get very, very different answers, and they're all very useful and reasonable answers, right? So if you ask an engineer or a DevOps person what they care about, they might say, yeah, I want to know how my instances are doing, because let's say one of them dies, I need to replace it, so I want to know as fast as possible. But if you ask a service owner or microservice owner, they might say, you know what, instances are great, but I really want to know how my service is doing. Is my searches, are they responding within a certain period of time or stuff like that? And if you ask the big boss or the CEO, they might say, microservice. I want to know if my company is meeting its SLA requirements, which is kind of very broad. And all of these are valid, and your metric system must support all of these use cases. So let's look into sort of what you might need to answer these kind of questions. And the answer is really some kind of scalable analytics, right? Because that's what you do to the metrics to sort of get these kind of answers. So in the first example of sort of per instance health, this is the most easy use case that most metric systems are able to deal with very well. All you need to do is query these time series representing different servers or instances, and look at them, chart them, and maybe if they cross a threshold, you alert on them, right? So the only special thing you might need is some kind of scale out capability. What if your number of instances grows from 100 to 1,000? It should be able to handle that. So you need the ability to have some kind of scale out, right? When you talk about microservice health, now we are talking about aggregations. What is my average CPU across a cluster? What is the total number of API calls that my service is handling? What's the 99th percentile latency of this service across the whole cluster? Those are the kind of answers that you need to sort of monitor the health of the service in general. And the other thing you would need is combines. So one of the things you will find is that a lot of times the raw metrics that your services will send you are not in the form that are ideal for monitoring. So let's consider a Memcache. So Memcache server might say, I've had so many hits and so many misses over the last some period of time. Now the number of hits and misses, it goes up and down based on how many hits are happening, time of day and whatnot. So they're by themselves not so great. What's more useful is the cache hit ratio, which is what you would get by dividing one by the other. So that's combines, where you're taking similar metrics, 2 different or 3 different ones, and you're combining them into the thing that you care about, right? The last use case of overall system health, that is the most interesting. There, you need the ability to do joins. Joins means combining data sets of different types, like system metrics, application metrics, cloud provider metrics, together into a uniform computation. So for example, let's say you were interested in capacity planning and you want to know how much, how much infrastructure to deploy. Let's say, again, for the search service that we were talking about. So you might calculate the average CPU of your cluster. You might calculate the sum total of the API calls that have happened across the cluster. So one's a system metric, one's an application metric, and then you combine them together to find out how much CPU you need for some number of API calls, right? So there, the 2 things that we did was we combined 2 different data sets, and we also did sort of thing called chaining or analytics pipeline, because we are processing data from individual data types, and I'm combining them. And as I mentioned in the example, it's very reasonable, and you should expect to have to do that, right? So you need the ability to do joins as well as chaining. In terms of best practices, obviously build an analytics system that can do these kind of things, or choose one that can do these kind of things, right? But just doing that is obviously not enough. In this case, you need to do more work. Even if you wanted to do joins, you need to model your data, which is how you send or model the data into the system. You need to model it to make it amenable to joining. For example, at SignalFX, one of the things we do is we put, for example, an instance ID, the Amazon instance ID, in all sorts of stuff that we report. So for example, the CloudWatch metric is obviously providing it from Amazon. The host metrics that CollectD is reporting, it also sends the same instance ID as a way. And then the Docker containers that are running in it, they also send it, and so do our application metrics. So now it's great because I can use the container ID as my join key, and I can associate metrics of different types, right? You get the idea. And this is the same pattern that you can repeat in various areas. So based on your use cases, you need to model your data well, right? The last best practice would be that if you have a system like this, which is very nice and very powerful, you should focus on what's important first. So instead of looking at lots of things in a piecemeal and micro fashion, look at what's important. What are your key performance indicators? What are the SLA related stuff that are important to you? Focus on those, build those using your analytics, and alert and visualize those first, because that's what is most important to your organization. And then when you see a problem, obviously you can drill down, right? So that would be about sort of getting holistic views. And the last lesson that I want to talk about is about timeliness. So timeliness is becoming more and more important. Obviously, the world is becoming faster and faster. Everybody wants things faster, right? There's a proliferation of SaaS services now, right? As a SaaS service, SignalFX is in charge of sort of maintaining our SLAs, and then we depend on SLAs from other companies. And if we can't do that, then it's game up. And it's becoming harder because the world is becoming, as I said, faster and more complicated. For example, Docker containers might live for minutes, right? And Lambdas live for milliseconds for that. And then in general, things are becoming faster. And also because of microservices and whatnot, just software is becoming more and more complex. For example, SignalFX is built with, 15 or plus different microservices, which are all sort of working together. Imagine the kind of interactions that they might have. They're extremely hard to predict. And when there is a problem, it's hard to know what caused the problem. But in order to maintain my SLA, I need to do that really, really fast. And so that is the challenge. And we don't have time, as I was mentioning. Let's say you are a SaaS service which has 3 nines of uptime. That means you only have 43 minutes per month of total downtime, right? That's not much because you have to find and fix all your problems within 43 minutes. If you are looking at 4 nines, that's like 4 minutes per month. At that point, I don't think like humans are even capable of reacting at this speed. And so you might need sort of automated triage and automated remediation. And what contributes to time to resolution? So let's say, so assumption here obviously is that you have a complex system. You're obviously not looking at things all the time like manually. You're depending on some kind of a monitoring or metric system to tell you the problems happened and then taking action. So what are some of the things that are contributing to sort of the time to resolution? The first thing is obviously how often you're measuring the things that you care about, right? So if you measure things much less frequently, chances are you won't find out about a problem until a long time has passed. Nyquist's theorem says that if I'm going to monitor something every minute, I need at least 2 minutes to know that something is off. The reason is a single outlier data point does not a trend make. I need at least 2 to sort of confirm that something is really, really not working well. And the reverse is true. So let's say you fix the problem. Now you need to validate that it actually fixed the problem. So you need another 2 minutes to see the same metrics sort of go down to the normal pattern. So that's 4 minutes with 1 minute sampling. The second thing is just by monitoring things frequently, you obviously magically things don't happen. There needs to be something that is minding this, that is looking at the incoming data and raising alerts when necessary, right? So the time that your analytics and alerting system needs, you need to add to this list. And then finally, it's the time for the humans. So the human sees the alert, they go, or maybe a bot. So they go and then look at, hey, what might be the problem? Let me go and deploy some kind of fix and validate that it happened. So these are the things that contribute to it. The core lesson, if you would ask me, is that it's hard as is. Provide your humans, the guys who are actually doing the fixing, as much time as you possibly can, because there isn't much time, right? That means your metrics and alerting system really needs to be fast. Like that's the single lesson as far as I'm concerned. And the way you might do that is coupled. So one is you need to have a high frequency monitoring, right? As I mentioned, 1 minute may be too much for 4 nines. You will never reach 4 nines with a 1 minute resolution monitoring. So you need to measure things quickly so that you have a better chance of knowing when something may be off, right? And at SignalFX, we, for example, measure every second. And this is we are not unique. We are seeing a trend among our customers where all of them are moving towards more and more sort of frequent monitoring. The other thing is that while, like I said, measuring frequently is great, but how often can you know that something is really off? How fast is your alerting analytics system? If, for example, you have an analytics system that's, polling the stuff that's coming in every 5 or 10 minutes, you already lost the game because it's too slow. What you need is something that can produce the alerts as soon as the data came in. So that's the other thing. So you need to have fast measurements, frequent measurements, as well as fast monitoring, fast analytics, right? And in terms of final thoughts, I really feel that as a reason of that, like event-driven future is what really awaits us, in the sense that we don't want to be polling things, we want to be acting on things as they happen. So for example, as soon as maybe I measured the CPU on a server, I need to send it to the metric system rather than storing it somewhere and having someone else pick it up later. Like that store and forward system may be too slow. Same thing with analytics. As soon as your data comes in, if you were data driven, if you were driven by when data arrives, then you have the best chance of knowing and raising that alert as soon as it happened, right? And so both your analytics as well as your data collection, I think if they're event driven, I think that provides the best chance of sort of handling SLAs, especially in this world. And things are only getting faster and faster and faster, and we're having lesser and lesser time, right? So I'm going to end on a sort of a shameless plug, obviously. So if you have sort of the right kind of processes and best practices in place, things actually can work very beautifully. So a customer of SignalFX called Tapjoy, they use us to monitor, among other things, a REAC cluster at high frequency. REAC is a NoSQL database that they use to sort of power their application. And what they have blogged about is that using sort of signal flow analytics, they are able to detect problems in less than a minute, where if the REAC cluster has a problem, they know right away. And frequently, they are able to deploy the fix before that error has a chance to sort of significantly affect their application. And what they say is that it saved them thousands of dollars, right? So having this works. That's where I want to end. It was sort of my dream to do this talk, and I hope you had a chance to dream along with me. I'm happy to take questions now, and also we'll be at the booth for right after this talk if you want to come by and discuss. Thank you very much. Yes?
One of the problems with monitoring is actually making sense of the data you collected. And the typical monitoring system will have a threshold of this minimum and maximum. I mean, you need actually heuristics to, or to some extent, artificial intelligence or machine learning to actually making sense of the large amount of data. Have you guys done anything in that?
Yes, so the question is that it's hard to get a sense of what the data is, and perhaps static thresholding doesn't always work, and you need some kind of machine intelligence and heuristics. The answer is a resounding yes. A lot of times, like I was mentioned, if you have like patterns that are sort of user-driven, like if I'm a consumer website, I'm going to have daily and weekly fluctuations and so on. It's very hard to say, hey, tell me if the number of errors goes above 80. Like, what does it even mean, right? What you really need is more smarts, more machine intelligence to sort of tell you what to do. So yes, so SignalFX, we are actually significantly investing in that. We already have a functionality which will, for example, given a data set, it can say, I'm going to alert you when there is an outlier, right? And it doesn't matter what the data set looks like. If there's an outlier, you will be told. So you don't have to tell us how the data should behave. We will look at that. Similarly, cyclical anomalies is another great example where you can look at the past behavior to see what it should be behaving like now, and it will automatically sort of tell you that something looks off. And so, yes, and we are also building a platform where we have signal flow analytics, which is also programmable, where the customer can implement data science algorithms and deploy what they want. So, of course, we are doing that too as an aid to customers, but then it's also available as a platform for others to use. So, yes, we are definitely investing in it. Yes.
You just mentioned high resolution per second. And how can you get the data longer? Because once per second is a lot of data points.
Yes, it is a lot of data points. So what we do is you can keep it. I mean, it's a question of storage in some sense. If you have a lot of storage, you can keep the data for longer. But so there's sort of two use cases. One is you want to look at stuff in the past, right? And you may or may not want to keep high resolution data. It really depends on your use case. The other is you also want to alert, because that's one of the primary use cases. Is you want to know when things are bad, right? And so for that case, you really don't need to keep high resolution, let's say a year back. As long as you're able to detect problems quickly, that's good enough, right? So again, it depends on the customer and on the use case. Some have requirements for keeping this longer, some for shorter. But in general, I think the main use case is especially as things are running. It's almost like air traffic, like the airplane, like as I'm flying, I need to know how things are doing. I need high resolution. I need to get alerted at high resolution. I think that's the key. And the other one is a less common use case where you may want to go and look back at things. That depends on, I think it's a database capacity question. Right?
One more question is about the create alarm. You turned out for our experience, there are so many false alarms.
Yes.
So you react quickly, but the problem comes within 5 minutes, and the actually customer intent may be already gone.
Right.
So how you deal with that?
Yes, so that's a good question. So the question is, if I have too many alarms firing, like how do I know? Because it's probably too busy or whatnot, right? This is kind of why I mentioned that I think it's very important to focus on the KPIs rather than the individual things. So I think, for example, if I had a service which is deployed across 1,000 servers, I may set up alarms on a per instance basis, but my main important ones will be, how is my service performing overall? Like, for example, when I was at Facebook, they had like tens and thousands of servers. There would always be a bunch of failures, right? And the SRE team, if all they did was handle those alarms, they would never survive. So what we did was we expected that. So what we looked at is the service affected? If it's not, sure, I'll expect some failures, I'll go fix them tomorrow morning. So that's why focusing on the key things, I think, is very important. And analytics capabilities that you have allow you to do that. So if you have that, use it, right? That would be my answer. Yeah. Yes? So SignalFX, we use, I think, Cassandra, and we have had talks and blogs about that too, about how we use it. So it's basically been built in a way where it's not affected by bursts. So it's not, we don't try to optimize one use case versus the other. The secret's that, because our best and worst case performance tends to be very close by, because the way we have modeled the database. For good or bad. But yeah, we use Cassandra, but we are also sort of looking at other alternatives right now, and who knows what tomorrow brings. But that's what we use now. Any other questions? Cool. Thank you very much.